Alright guys, so we are doing FRQ practice number 1. Take a look at your first question here. So it gives you a differential equation. Remember, that just means that your equation has a derivative in it. That's what the dy dx is. Then it says let f of x be the particular solution with the equation that f of 0 is 1. Okay, so if f of 0 is 1, that means that 0, 1 is a point on the curve. Okay, then it says Part A, a portion of the slope field to the differential equations given below, sketch the solution curve through 0, 1. So remember, all that means is I'm going to go to 0, 1, which as you can see, the x-axis and y-axis are both labeled. So if this is 3, this is 2, this is 1. And then I just need to basically follow the shape of the graph. So I'm going to just kind of go like that. Now, keep in mind that as long as you have relatively the right shape, they're not going to judge how many ticks you went up or how many you went down. It's just that shape. Okay? Go down to part B. It says write an equation for the line tangent to the curve at 0, 1. Okay, well then I already have my point, which is 0, 1. Then I need my slope. Remember, to find the slope, you're doing dy dx at 0, 1. So it'd be 3 minus y, which is 3 minus 1, times the cosine of x, which is the cosine of 0. 3 minus 1 is 2, cosine of 0 is 1, 2 times 1 is 2. So from there I can set up y minus 1 to x minus 0. There are different representations of that. You could solve it for y if you want to, but I'd say just leave it in point slope form. Okay, from there, part C says to find a particular solution. Remember that means that you need to separate and then integrate. Okay? So, if I am separating my dy dx, it was originally 3 minus y times cosine x. Okay, my first step is going to be to take this 3 minus y, and I'm going to divide it across to the left side. Now keep in mind that if it was on top when I divide it over, now it's going to be on bottom. So it'll be 1 over 3 minus y dy. And then on the other side, I'll keep my cosine x dx. Integral, integral. Now remember, at this point, I've already gotten a point on the AP test for separating. Okay, so next I'm going to do u equals 3 minus y. That means that du is negative 1 dy, because I'm taking the derivative of 3. Well, that's a constant, so it'll be 0. And then the derivative of minus y will just be the negative 1. So dy is the same as negative du. So 1 over u negative du. Negative can go to the outside. Really, that's the negative ln of u. And then I know that really that's the negative ln of 3 minus y. So several steps there, okay, to do our u sub. So from there, integral of cosine is going to be sine x plus c. Remember, at this point, I already have 3 points. 1 for separating, 1 for integrating over here, 1 for integrating over here. I'll get a 4th point if I find my constant. So I'm going to carry this down since that didn't need really any extra steps. And then I'm going to work on getting my y by itself. So to get rid of the negative here, I need to multiply the whole thing by a negative 1. So that's going to give me a positive ln of 3 minus y. A negative sine x plus c. And remember that since my c is already ambiguous or unknown, when I multiply by negative 1, I'm just going to leave it as a plus c. Then I'm going to e both sides. E and ln are going to cross out. 3 minus y is going to come down. And then remember that when I drop my c here to the front, that allows me to drop these absolute value bars. So when that c comes down, since I don't know what it is, it's the same as putting a plus or minus on that side. So I have 3 minus y is c e to the negative sine x. Then I'm going to move my 3 across. It'll turn into a negative 3. And then I'm going to change all my signs by multiplying by negative 1 to cross out that negative in front of the y. So from there I have y equals c e to the negative sine x plus 3. Okay, that is my general solution. But then remember, I don't need the general, I need the particular solution. So I'm going to use my ordered pair. F of 0 is 1. So 1 is the answer. Let me draw a little line here. When I plug in CE to the negative sign, X is a 0. Okay, well think about sine of 0 is 0. E to the 0 is 1. So really this is 1 equals C plus 3. Minus my C across C is negative 2. So I have Y equals negative 2 E to the negative sine X plus 3. And that'd be my solution. Okay? Alright, go ahead and turn the page. Good job. Alright, so next one, we have a graph of f. Says to find g of 3, and then I notice that right here, my g is given to have an integral already built into it. So for part A, when I'm finding g of 3, remember I'm plugging that in right here, so it'll be the integral from negative 3 to 3 of f of t dt. Now remember that this is already a graph of f. So if I'm wanting to find the integral from negative 3 to 3, I'm going to be calculating the area from negative 3 here to 1, 2, 3 here. Okay? So I have a big triangle up top, and then I have a little triangle below that right here. Okay? So I'm going to do my big triangle first. Remember that it's 1/2 base times height. 1/2, my base is 1, 2, 3, 4, 5 units across. My height is 1, 2, 3, 4 units tall. 5 times 4 is 20, half of that is 10. Okay, looking at this little shorty triangle right here, okay, it's going to be 1/2. My base is 1, my height is 2. 1/2, 1 times 2 is a half of 2, which is 1. Now remember that my 10 was on top, my 1 is on bottom, so my total for part A is going to be 9. Okay, go to part B. Part B says, on what intervals from negative 5 to 4 is the graph of g both increasing and concave down? Okay, so remember that for g to be increasing, g prime needs to be positive. For g to be concave down, g double prime needs to be negative. So I need to look at the signs of g prime and g double prime. Well, then that means that I need to find what functions those are. So I'm going to rewrite this up here. So if g of x is the integral from negative 3 to x f of t dt, that means that g prime of x is going to be, take your x, plug it in, f of x. Because remember, when I take the derivative of an integral, it doesn't change my equation, it only changes my letter. Okay, then g double prime of x is f prime of x. Now remember that if this is a graph of f, which it is, okay, then f of x are going to be my y values, and f prime of x are going to be my slopes. So let's look at our graph. We want g prime to be positive. Remember, those are y values. And we want g double prime to be negative. That's my slope. So I want to be above the x-axis if I want positive y values, and I want to be decreasing, which is a negative slope. So look at my graph. I see that I'm above with a negative slope here, and I'm above with a negative slope here. So there are actually 2 intervals where that happens. So for part B, I'm going to put my answer up here in the corner. It would be from negative 5 to negative 3. Union, and then it would be from 0 to 2. Because remember that I wanted g prime, which was really f of x, to be greater than 0, and I want g double prime of x, which is the slope of f, to be less than 0. Now, there are other ways that you could justify that. You could have said that f is greater than 0 and not put the g prime. Or you could have said that f is increasing, which is the same as a positive slope. Okay? Go down to part C. So part C gives you a new function. It tells you that h of x is going to be g of x over 5x. Okay, so let's think about that for a second. If I want h prime, that's me needing to take a derivative, then I'm going to need to do quotient rule. Okay, I'm going to need to do quotient rule. So when I take the derivative using quotient rule, remember I break up into a high and a ho. My high is g of x. My ho is f of x. So d high is the derivative of g, which is g prime of x. And d ho is the derivative of 5x, which is 5. Then remember my derivative is ho d high minus high d ho. Now, as this is a free response, I'm going to make sure to label stuff. So if my original function was h, my derivative function is h prime. And then I want ho d high minus high d ho would be 5 times g of x over ho squared, which is 5x squared. Now, I don't want h prime anywhere. I specifically want h prime at 3. So from here, I'm going to find h prime of 3, which would be, plug in my 3 right here. 5 times 3 is 15. And then g prime of 3, I'm going to have to find in the table here in a minute. Then minus 5 times g of 3 over. Down here, 5 times 3, this is 15 again, but I want 15 squared. Okay, then from here, I need to find this value and this value. So remember that actually, I found g of 3 earlier. Do you remember? That's what we found in part A right here. Okay, g of 3 already came out to be 9. So this is a 9. But g prime of 3, I'm going to have to go back and find. Now remember, as we wrote up here, g prime is the same as f. Okay, g prime is the same as normal f of x. So if I want g prime of 3, that's going to be the same as f of 3. And remember that f of 3 is really a y value. So at 3, what's the value of the function? Well, let's count. So if I'm here, I'm at 1, 2, 3. My y value is negative 2. So I'm going to have 15 times negative 2 minus 5 times 9 over 15 squared. And if you wanted to reduce that more, you could, but it would not be necessary. That'd be negative 30 minus 45 and then over 15 squared. Okay, and you could probably reduce that eventually, but since it's an FRQ, who cares? Don't waste your time and don't risk making a mistake. Okay, so last part, part D. Gives us a new function again. Tells us that it's f of x squared minus x. And it asks you to find the slope of the line tangent to the graph of P at the point where x is negative 1. Now, if you immediately see the line tangent and start writing a tangent line, you're wasting your time. Because I don't need the whole equation, I really only need the slope. So remember, to find the slope, I need to take the derivative. So p prime of x equals, okay, first I'm going to look at my outside function, which is an f. The derivative of f is f prime. X squared minus x stays the same, but then I need to multiply by the derivative of the middle, which is 2x minus 1. Now, the way that I've written this is actually incorrect. I need to go back and put parentheses around this. Because remember, it's not only the 2x being multiplied here, it's the whole thing. Okay, so some of y'all need to be really careful about that. Okay, then from there, I don't want p prime anywhere. I want it at negative 1, as it says in part D. So p prime of negative 1 equals f prime of something. So let's figure this out in here. Negative 1, if I square it, is going to be a positive 1. But then I need to minus a negative 1. That's going to come out to be a plus. So really, I want 1 plus 1, which is 2. Okay, then in my second parentheses, I'm plugging in a negative 1 here. Well, negative 1 times 2 is negative 2 minus 1, which is negative 3. Okay, then from there I need to go back and find f prime of 2. Now remember that if this is a graph of f, then f prime is going to be the slope. So you have to be really careful for which letter you're looking at. So come up to your graph at 2. What's my y value? Okay, oh actually hold on. I don't want f of 2, I said that wrong. Okay, I want f prime of 2. This is already a graph of f. So if I want f prime, that's going to be the slope of the graph at 2. So if I'm looking right here, I need to count the rise over run. So I can see that if I go down 2 over 1, down 2 over 1, my slope is a negative 2. And that's what I'm going to use for my f prime value here. So if it's negative 2 times negative 3, that'd be positive 6. And that, my friend, would be your answer. Okay, go ahead and turn the page. Let's see what's left. Oh yeah. Okay, next one. So it says, find the average acceleration of the train from 2 to 8. Now, you should notice that if this is velocity, and they're asking you for average acceleration, there are only two averages. It's either the average value or the average slope. So think about if this is velocity, and I want acceleration, that is the slope, I'm doing average rate of change then. If it was velocity and I wanted average velocity, that would be average value. So I'm going to do v of 8 minus v of 2 over 8 minus 2. The velocity of 8 is negative 120 minus velocity of 2 is 100 over 8 minus 2 is 6. Now let's talk about units here. My units on top were velocity, which was meters per minute. But then on bottom, my 6 was in minutes again, so now it's meters per minute squared. Okay. So you could simplify that, I guess, one step further if you wanted. That'd be negative 220 over 6 meters per minute squared. Not really necessary, but you could do it if you wanted to. Okay? All right, part B says, do the data in the table support that the velocity of train A is negative 100 at some time between 5 and 8? Now notice they're giving you a specific interval. So if I wanted to look specifically from 5 to 8, look at your y values. Oops, I circled the wrong thing. Okay, from 5 to 8 would be here. I want to know if it has to equal negative 100. Well, if the velocity goes from positive 40 to negative 120, remember that IVT guarantees it has to hit every intermediate value or every value between those. Now, that only applies if it's a continuous function, but I want to draw your attention right here to the fact that it says train A's velocity is a differentiable function. Remember that if it's differentiable, it's also continuous. So, part B. IVT guarantees this because, let's say, VA is a continuous function because it's differentiable. And the value that I want, which is negative 100, is between the velocity A of 5, which is 40, and the velocity A of 8, which is negative 120. Okay, and I would think that'd be the shortest way for you to write that part out. Okay? Alright, go down to part C. Part C says, at time 2, train A's position is 30 meters east of origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin at time 12. Use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the time at 12. Okay, lots of stuff here. Let's kind of break it down. We want the position at time 12. So the first thing that I'm going to set up is that I want to know the position at 12. Now remember, X and S are the letters for position. Okay, so I'm going to pick X, but you could pick either one. So X of 12 equals. Now, remember, this is what I want. Then there had to be a position that I already have. So go back and read this sentence right here. It says at time 2, the position is 300 meters east. So that means that my X of 2 is 300. So I'm going to write that maybe over here to the side. X of 2 equals 300. Okay, plus the integral from 2 to 12 of v of t. And then remember that whatever goes in here should always be the derivative of what's on the outside. Okay? Then from here it tells me to use a trapezoidal sum with the subintervals in the table to approximate the position. So that trapezoidal sum is applying just to this part. Okay? Trapezoidal sum. So let's rewrite. X of 2 we know is 300 because they gave me that. Plus, and then in here I'm doing a little bit of trap rule. So remember how that goes. You're going to do 1/2. You're going to add the y values. So 0 plus 100. Then you're going to multiply by the distance or the delta x between them. So if I went from 0 to 2, my delta x is 2. Plus. Then I'm going to go from 2 to 5. My y values are 100 plus 40. But then if I went from 2 to 3, my delta x on that subinterval, from 2 to 5, my delta x is 3. Plus, next one. Going from 5 to 8, my y values are obviously 40 and negative 120. And then the distance from 5 to 8 is 3 a second time. Plus, last one, 1/2. From 8 to 12, my distance is 4. And my y values are negative 120 minus 150. Now, if you wanted to, you could put plus negative 150. Okay, honestly, doesn't really make a difference there. And then remember, this is good enough. Okay, nobody cares. Don't add it up. I mean, if you had a calculator, maybe, but unnecessary. And what if you make a mistake, right? Okay, part D. A second train B travels north from the origin station. At time t, the velocity of train B is given by blah, blah, blah. And at time 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between the trains is changing at time 2. So let's talk about some different important things here. So the first thing that I'm going to do is draw a picture, and I'm going to do it on another sheet of paper just so that I don't take up all my space here. Okay, so let's say that origin station, we're going to just put right in the middle. So here's origin station. Okay, let's go back and review. So it says that train A is moving to the east. So never eat soggy waffles. So train A is going this way. Then it says that train B is traveling north from origin station. So train B is headed that direction. Okay? Then it says how fast is the distance. Find the rate that the distance between the trains is changing. So remember that this is my distance here. So C is going to be the distance between the trains. Okay? So the first thing that you should be kind of thinking is, oh man, this is a related rate. I can't wait to review that. Okay, me too. Funny you say that. Okay, so remember that the speed that train A is traveling, that's going to be my d/dt. And remember that the speed that train B is traveling, that's going to be my dB dt. Remember that the distance, how fast that's changing, we're going to call that dC dt. So let's set up our find, given, and our when. So it says, at time 2, the train is 400 meters north. So at time 2, distance B is 400 meters north. So that's going to be my when. And then I'm going to put at time 2, but I want you to notice that all of these points are at time t equals 2. Okay, so it says, train B travels north. It says it's 400 meters north. Got it. Let's go back and look at part C. It says at time 2, notice that's the same time, train A is 400 meters east. So that means that A is 300 meters east. Okay, now also keep in mind that's at time 2. Okay, so we want to kind of think about that, but since that's the time we care about anyway, who cares? Okay, then it says we want to find the rate that the distance between the trains is changing, so we want to find dC dt. And then our given, we need to look for our train A and our train B's rate of change. Now, the way that we're going to get these is going to be different. The first thing I want you to notice is that dA dt is the rate train A is moving. So think about in your question, what is the rate that something is moving called? The rate that something is moving is called its velocity. And if you look back in your chart, we know the velocity of train A at time 2. So come back to here. Train A at time 2 is going 100 meters per minute. So at 2, train A is going 100 meters per minute. So my given is going to be that dA dt is 100. But I also need to know dB dt. So let's see if we can find dB dt. So notice that it tells me here my second train, they gave me its velocity, but it's in the form of an equation. Okay, well that's not so bad. If I want to know the velocity of train B at time 2, then all I need to do is plug 2 into that equation. So I have that V of B equals, and then it says it's negative 5t squared plus 60t, and then plus 25. And then I need to take my 2, plug it in. So, velocity of train B at 2 is negative 5 times 2 squared plus 60 times 2 plus 25. Well, 2 squared is 4, so that's a negative 20. 60 times 2 is 120. And then negative 20 plus 120, that's 100 left over, plus 25 is 125. Okay, kind of annoying, a little bit of extra work. It would have been nice if they'd just given us a table, but they didn't. So we now know dA dt and dB dt, we want dC dt, and we know A and B. Let's set up our equation. So remember that the equation that relates the three sides of a right triangle is A squared plus B squared is C squared, Pythagorean theorem. We're going to take the derivative. The derivative of A is 2A dA dt. The derivative of B squared is 2B dB dt. And then the derivative of C squared is 2C dC dt. Now, as I'm going back and looking through that, I want to make sure that I have all the stuff that I'm supposed to have. So, I know A, it's 300. I know dA dt, it's 100. I know B and dB dt, okay, 125 and 400. I want dC dt, but I don't know C. That's a problem. So I want you to think about for a second that if train A is 300 away and train B is 400 away, okay, think about just for a second. This side is 300, this side is 400. Okay, in kind of a sneaky way, can you figure out that third side? Think about 300, 400. Okay, think about a 3, 4, 5 triangle. If this one's 300 and 400, then this one has to be 500, that's my C. So when I plug in, I'm going to add to this that my C has to be 500 if the other two sides are 300 and 400. So let's plug stuff in. So 2 times A times dA dt plus 2 times B times dB dt equals, oh no, 2 times C, which was 500, and then dC dt. You like that? Okay, good. So from there, 2 times 300, that's 600. 600 times 100 is, I'm just going to leave it, honestly. I don't even care. Okay, then 2 times 400 is 800. And I am not about to multiply that by 125. Not because I can't, but because, remember, we don't want to waste time. And then this in here is going to be 1,000 dC dt. Well, then from there, if I want to get rid of the 1,000 multiplied by the dC dt, I just need to divide by that. So my final answer, okay, keep in mind I'm being lazy here because it's multiple choice, is going to be this stuff divided by 1,000. Boom, you're done. Got it? Now, obviously on the AP test, they'd give you plenty of space to work that out. I just write really big, draw pictures, you know. So, hopefully you got it. Okay? The other thing I would go back and just double check on is your units and stuff. Sometimes it'll say indicate units of measure. So here it did not, so we're off the hook. But a lot of times they do state that. Okay, we are going to do just one more. We're going to do this guy right here. So we have a graph, we have an equation. Okay, here's our region. Okay, so it says, let R be the region enclosed by the graphs in the horizontal line. Now, this is a calculator question, so I'm going to just call this intersection x equals A. This intersection x equals B. Now, I do want to point out to you that a lot of y'all on your test were like, oh, this is 0. Okay, when on your test, it actually was like 0.1 something. So you do need to find these in the calculator. I would not just assume that since it looks like it's 0 that it is. Now, if you do a little bit of algebra here, they do actually intersect at 0. Because if I plug in 0 minus 0 plus 4, that comes out to be 4. And this one is a 4. So if I do part A here, and I'm really looking for those y values, this first one is 0. But that is not always the case. All right, so part A. Okay, find the volume of the solid when R is rotated around y equals negative 2. So y equals negative 2, I'm going to draw it in down here. Okay, this is going to be my axis that I'm revolving around. And I'm going to draw my r's in. Remember that capital R is going to go from the axis of revolution to the farther away shape, or border. And little r is going to go from the axis of revolution to the inside. So little r, capital R. Okay, let's write our equations. So capital R is going to be top minus bottom. My top function is the flat line y equals 4. My bottom function is the flat line y equals negative 2. So it makes sense to me that this is going to be 4 minus negative 2, which is 6, because both of my lines are flat, so they're always going to be 6 apart, regardless. Okay, little r is going to be this equation, minus negative 2. So I'm going to call it f of x minus negative 2. Now, I'm going to rewrite that as f of x plus 2, just because I don't want to have a bunch of extra negatives and random stuff to have to worry about. Okay? So, from here, I'm going to put volume equals. Remember that whenever you are rotating, it's going to be pi capital R squared, which is 6 squared, minus little r squared, which is f of x, plus 2, make that a little bit rounder, squared dx. Okay, then the other thing is we need our endpoints, which remember are a to b. Also keep in mind that we do know that a is a 0 at this point, but you need to find these numbers, obviously, if it's the real AP test. Okay, I just don't have a calculator. Okay, part B. Okay, it says region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis, that tells me it's dx, is an isosceles right triangle with a leg in R. Find the volume of the solid. So the first thing that I'm going to do, besides redraw my picture here, okay, here's my graph. Okay, here's my region, is I'm going to draw in my base. Now remember that your R's have to be touching what you're rotating around, but if it's a base, it's not allowed to go outside of your region. So I'm perpendicular to the x-axis, that means I'm running this way. That's my base. And remember that since it's up and down, this is the x-axis, then when I do my base, it's going to be top minus bottom. So it'll be 4 minus f of x. Next, I need to consider my shape. It tells me that I want to be an isosceles right triangle with a leg in the region. So area of a triangle is 1/2 base times height. But then if it's an isosceles right triangle, that means that these two sides have to match each other. Also notice it says I want my leg in R, so remember the legs always match each other. So that means that the base and the height are actually identical. So I'm going to replace this here with 1/2 base times base, which is 1/2 base squared. And then remember from there you're just doing your volume. So it'll be integral of 1/2 base squared, and then remember that my base was 4 minus f of x. Okay, then from there you'd have to find your a and your b and work your integral. Okay? Good job. Now, if this was a calculator problem, which it is, you would have to put that in the calculator to get your answer. Okay? All right, last part, part C. The vertical line x equals 2 divides the regions into 2 equal areas, right? But do not solve an equation involving integral expressions whose solution gives the value of k. So that means that my k, let's say that it's going to be maybe like right here. Okay, I want to pick the value of k so that it cuts this area to be equal exactly to that area. So if I want these sides to come out the same, there are several different options. Y'all got kind of creative on the mock exam, or whatever I guess it was that I was grading this. Maybe it was your normal test. But I'm going to set it up from a to k. Top minus bottom is 4 minus f of x dx. And then a lot of y'all did the integral from k to b of 4 minus f of x dx. Okay, that would get you the point. Because I'm saying that my integral from a to k is equal to my integral from k to b. Okay, that would be fine. Now again, you need to know what these numbers are. You can't leave them ambiguous. You would have had to go back and find these. Okay, the other option, which a lot of y'all did correctly on your test, was you said the integral from a to k of 4 minus f of x dx is equal to half, and then you set up the integral from a to b 4 minus f of x the whole way across. So you're basically saying it's half of the total area. Okay, that would have been fine. The other option, okay, and the last option I'm going to give you is that if you actually found this area, then you could have like just cut it in half basically and set it equal to that instead. So if you had actually calculated this area, then you would have just done half of whatever that number is. So your third option would have been that from a to k, 4 minus f of x dx, it should be equal to half of whatever that total area is. Now, a lot of times you would have already found that value, so it would have been like, oh, you're just going back and looking at part A. But since you haven't found it yet, I might go with one of these two options just because it's less work. Okay, good job.